Okay, now, like we've done equations, adding and subtracting, multiplying and dividing, and now we're going to move on to inequalities, okay? So inequalities, as you'll find out, are a lot like equations. So right here, the question is, what is an inequality? An inequality compares two quantities, okay? It compares two quantities. So an inequality symbols is less than. So less than looks like this. It's almost like an L, you know? See how my L, if I were to write a really bad L like that, is less than or equal to, so we put less than and then an equal sign underneath, is greater than or is greater than or equal to, okay? So we're going to write each sentence as an inequality using a variable, okay? So a number is greater than or equal to 5. So I'm going to underline it's greater than or equal to, okay, because that's going to tell me what inequality symbol to use. And a number, we're going to use the letter N for our variable. So I'm going to say a number is greater than or equal to. So look for that one. Greater than or equal to 5. Okay? A number is less than negative 17. Number less than, so number less than negative 17. Okay, so all we're doing is we're reading the inequality and we're going to write it out. 40 is less than or equal to a number. So 40, we're flipping it, is less than or equal to a number. 9 is greater than a number. So 9 is greater than a number. Number 5 is a number is fewer than. Fewer than, I'm going to come over here. Fewer than is the same as less than. So we're going to write fewer than, and we're going to give it the inequality of less than. Okay, so make sure you write this down right here. So that's another reference. So fewer than, a number is fewer than 14. Okay. Then I have a number is at least negative 3. So hear this out. When I say a number is at least, when I say it's at least, it needs to be greater than or equal to, at least. So a number is, it's at least negative 3. So it's going to be at least negative 3 or greater than that. And that's another one. I'm going to put my phrase right there. Okay. A number is no more than 1/2. So a number, no more than, which means, we're going to write this, no more than, it has to be less than or equal to. So it's saying it can't be more than 1/2, but it can be 1/2. So n is less than or equal to 1/2. Okay? A number has a minimum value. A number has a minimum value, so it has to be 9.4 or more. So I'm going to say minimum value has to be greater than or equal to, okay? So the minimum it can be, so greater than or equal to 9.4. Number 9, a game is designed for 13 and up. So 13 and up. So my game, I'm going to say G for game. So it has to be 13 and up. So it has the age, you have to be at least 13, but you have to be older. So the game is for people greater than or equal to the age of 13. Okay. The theater can seat up to 500 people. So if I were to say up to, I'm going to say it is less than or equal to. So I'm going to say seats. We'll say N for, okay. So the theater can seat up to. So it can seat 500, but it can't go above that. So I'm going to go less than or equal to 500. Okay? So yes, this is a lot, but these are great notes that you can use when you do your assignments, okay? Okay. A solution, so solutions, okay. So a solution to an inequality is a value that makes the inequality true. Determine whether the given value is a solution to the inequality. So they're asking, so here's how we're going to write this. X is greater than 16, and they're telling me X is 20. So I'm going to rewrite this. 20 is greater than 16. Well, is 20 greater than 16? Yes, so it is true. Okay. Number 12 says P is less than or equal to 5. Well, P is 8. So we're going to write 8 less than or equal to 5. Well, is 8 less than or equal to 5? No, that's false. That's false. 13. K is less than negative 13. K is negative 4. Let's think about our number line here. K is less than negative 13. Let's ask ourselves. Remember, when we're on the negative side of a number line, negative 4 is, we want to ask ourselves, if it's 4 is closer to 0 than negative 13. So negative 4 is actually greater than negative 13. So this is actually false. C is greater than or equal to negative 10. And they're saying C is negative 7. So let's put this down. Negative 7 is greater than or equal to negative 10. Now this is what's going to throw people off, the or equal to. Is it greater than or equal to? Well, negative 7 is closer to 0 than negative 10. So negative 7 is greater than or equal to, so it is true. Now I have 20 is less than or equal to A. A is 27, so I'm going to write 20 is less than or equal to 27. And is 20 smaller? Yeah. Okay, so we're going to say true. Now I have negative 1 is greater than M. M equals 2. Negative 1 is greater than 2. Well, let's ask ourselves. First of all, I have a negative and a positive number. So right away we know positives are always greater than negative numbers. So this one's actually false. Okay. We've got a bunch of these. Now, I know you don't love the decimals and the fractions, but let me tell you something, friends. These are great for practicing comparing and ordering decimals and fractions. So N is less than or equal to 3.1. N is 3 and 89 thousandths. So 3.089 is less than or equal to 3.1. Now, some people would say that's false because still, this has more digits than this, but we need to stack. Okay? So, if I'm comparing, 0 is less than 1, which makes the statement true. So I have F is greater than 13.04. F is 13.008 is greater than 13.04. Well, if I was to stack these, I'm going to put this underneath. 13.04 is actually greater than. So this is a false. False. Y is greater than 5.25. Y is 7.8. 7.8 is greater than 5.25. And if I just look at the whole number at the front, I already know that 7 is greater than 5, so that's a true statement. 60 is 0.3 is greater than or equal to V. So let's put this out. 60.3 is greater than or equal to 60.295. Now, if I'm comparing, my whole numbers are the same, but then I have a 3 and then I have a 2. So this would be true. 60 and 3/10 is greater than 60 and 295,000. So that's true. Always compare it. Ooh, the fractions. Whoa. A is greater than or equal to 2/3. A is 7/10. Now, you can do many things with this. You can make them, you can find the common denominator and then compare the numerators. You can convert these to decimals. So we're going to say 7/10 is greater than or equal to 2/3. Well, I know 7/10, I'm going to put this over here. It's 0.7 and 2/3 is 0.66 repeating. So I know 7/10 is greater than 66/100 repeating. So this is a true statement. Yes, it's a work. It's work, but it is what it is. Okay. N is less than 1 and 2/5. I have 1 and 4/9 is less than 1 and 2/5. Okay. So if I am going to, my calculator right here. Okay. I'm going to put this as a decimal. So to do this, you're going to type your UND, your mixed number, 1/4/9, okay? Enter. Then we're going to do second fraction decimal, and we got 1.444, okay? So I have 1.444 repeating is less than, let's do it 1 and 2/5. So 1 2/5, enter, second fraction decimal, and I get 1.4. So actually this is false. That's a false statement. Okay. Pause this. Okay. I have 1/4 is greater than Q. So 1/4 is greater than 3/20. So I know that 1/4 is 0.25. And I have 3 divided by 20, and I get 0.15. So this is actually a true statement. Okay. Then I have Z is less than or equal to 3/8. So I know, so let's put it like this. 1/2 is less than or equal to 3/8. Well, I know 1/2 is 0.5, and I know 3/8 is less than half, so this is actually a false statement. So let's, right here. So the set of all solutions of an inequality is called the solution set. We can graph the solution set of an inequality using a number line with an arrow pointing towards all possible solutions. So x is greater than or equal to 4 means x is a number that is greater than or equal to 4. So when graphing inequality, use an open circle for less than or greater than, and then use a closed circle for less than or equal to or greater than or equal to, okay? So when we graph these, I tell everybody what you have to do first is put your number in the middle, 2, okay? And then I look at my symbol, less than. K is less than. And I know less than is an open circle. So I put an open circle. And if it's less than, I'm going to the left. I'm just going to draw my arrow. And that's it. A is greater than or equal to 9. I'm going to put 9 in the middle. And greater than or equal to is a closed circle. And it's greater, so I go to the right on my number line. P is less than or equal to 1/2. Put 1/2 on your graph. Less than or equal to is a closed circle. Less than goes to the left. 5 is greater than X. Now hear me out. Put 5 in the middle. Greater than is an open circle. One second. Sorry. I kept getting interrupted. So 5 is greater than X. So 5 in the middle. Greater than is open. And 5 is greater. So that means X is going to be smaller than. Okay? You got to really read it. -3 is less than or equal to, closed circle, less than or equal to M. So M is actually going to go this way, bigger. Y is greater than 1.7, open circle to the right. Z is less than 2/3. So less than, it's going to go this way. Because we have to see, sometimes our variables are on the opposite side, but that's why we have to really read and think about what it means. So 9/4 is greater than or equal to X. So greater than or equal to, close circle. And if 9/4 is bigger than X, then X must be smaller. And that is it, my friends.